Have you ever wondered how you see the world around you? What makes the colors of a sunset so vivid? The answer lies in the fascinating structure and function of the human eye and the science of light. The eyes. The eyes allow us to see, perceive, and interpret the world around us through the detection of light and color. Parts of the eye: vitreous humor, ciliary body, lens, iris, cornea, sclera, choroid, retina, optic nerve, blood vessels. Vitreous humor. The vitreous humor is the transparent gel that gives the eye its shape. Ciliary body. Relaxing muscles makes the lens thin for distant vision, while contracting them thickens the lens for close-up vision. Power of accommodation. This ability to change the lens's focal length is called power of accommodation. Lens. The lens is a clear part that receives the light that enters the eye. It then bounces off this light to the back of the eye. Iris. The iris is the colored part in front of the eye. It helps screen and control the amount of light that enters the eye. Cornea. Light enters the eye through a thin membrane called the cornea. It forms the transparent bulge on the front surface of the eyeball. Most of the refraction for the light rays entering the eye occurs at the outer surface of the cornea. Sclera. The sclera is the white part of the eye. It is made of a tough material that protects the inside of the eye. Choroid. The choroid is the middle layer of the wall of the eye. It is filled with blood vessels that bring oxygen and nutrients to the eye. Retina. The retina receives the light from the lens. It is made up of rods and cones. The rods let the eye sense light, while the cones help identify color. Blood vessels. The blood vessels carry blood to and from the eye. They transport oxygen and nutrients to the eye. Now, the optic nerve transmits electrical impulses or nerve messages from the eye to the brain. Eye lens. The eye lens forms an inverted real image of the object on the retina, near point and far point. The near point is the closest distance for clear vision without strain, usually around 25 centimeter for young adults. The far point is the farthest distance for clear vision, and the far point of the eye is at infinity. Defect of vision. Sometimes the eye may gradually lose its power of accommodation. In such conditions, the person cannot see the objects distinctly and comfortably. The vision becomes blurred due to the refractive defects of the eye. Defects of vision and their corrections. Cataracts. It is a common eye problem that can occur with age. Cataracts can affect the power of accommodation by reducing the flexibility and transparency of the eye's natural lens. Cataracts correction. However, cataracts are treatable through surgery where the cloudy lens is replaced with a clear artificial one. Myopia, nearsightedness. A myopic person can see nearby objects clearly but cannot see distant objects clearly. The image is formed in front of the retina. Myopia correction. Corrected using a concave lens to bring the image onto the retina. The concave lens placed in front of the forms a virtual image of a distant object at a far point of the myopic eye. Hypermetropia, far-sightedness. Affected person can see far objects clearly but cannot see nearby objects clearly. The image is formed behind the retina. A person with this condition needs to hold reading material well beyond 25 centimeter from their eyes for comfortable reading. Hypermetropia cause. The focal length of the eye lens becomes too long. The eyeball has become too small. Hypermetropia correction, corrected using a convex lens to help focus close objects onto the retina. The use of a suitable power convex lens can correct the defect. Hypermetropia is corrected by using a convex lens which converges the incoming light rays before they enter the eye, making them appear to come from the near point, allowing the eye to focus them correctly on the retina. Presbyopia, affects people as they age, leading to difficulty in seeing nearby objects clearly. For most individuals, the near point gradually moves farther away, making it challenging to clearly and comfortably see objects up close without the use of corrective glasses. Cause gradual weakening of the ciliary muscles and reduced flexibility of the eye lens over time results in decreased ability to focus on near or distant objects, a condition often associated with aging. Correction, corrected with reading glasses or bifocal lenses, which have both concave and convex sections for distant and near vision, respectively. Refraction of light through a prism. The angle between the lateral faces is known as the angle of the prism. When a ray of light, P, enters a prism from air at its first surface, AB, it bends toward the normal line. At the second surface, AC, as the ray exits from the glass to the air, it bends away from the normal line. Due to the peculiar shape of the prism, the emergent ray, Fs, bends at an angle to the direction of the incident ray. This angle of bending is called the angle of deviation, represented as angle D in the activity. The angle of deviation is unique to prisms and varies with the prism's shape and the angle of incidence. Dispersion of light by prism. A glass prism can break white sunlight into a spectrum of colors. This happens because each color bends differently as it passes through the prism, creating distinct paths for each. Dispersion of light by prism. Rainbows in the sky are optical phenomena created by the dispersion and reflection of sunlight in the Earth's atmosphere. This occurs when sunlight enters water droplets in the air, bending or refracting the light as it passes through, and then reflecting it internally within the droplet. Rainbows. A rainbow is a natural spectrum that appears in the sky following a rain shower. It forms when sunlight is dispersed by tiny water droplets in the atmosphere. A rainbow always appears in the direction opposite the sun. The water droplets act as small prisms, refracting and dispersing the incoming sunlight, reflecting it inside the droplet, and then reflecting it again as it exits. This process of light dispersion and internal reflection results in the various colors visible to the observer. Atmospheric refraction. Objects may appear to waver or flicker when seen through hot rising air above a heat source. This happens because the hot air near the source has a different refractive index than cooler air, causing atmospheric refraction. Twinkling of stars. Stars appear to twinkle due to atmospheric refraction of starlight. As starlight enters the Earth's atmosphere, it continually refracts, making the star seem slightly higher than its actual position. Why planets don't twinkle? Planets, being closer to Earth, are seen as extended sources of light, made up of many point-sized sources. The collective effect of all these light sources cancels out variations in light entering our eyes, preventing planets from twinkling. Advanced sunrise and delayed sunset. The sun is visible a few minutes before the actual sunrise and remains visible for a few minutes after the actual sunset due to atmospheric refraction. This effect occurs because the atmosphere bends sunlight, causing the sun to appear slightly above the horizon before sunrise and after sunset. The apparent flattening of the sun's disk at these times also results from atmospheric refraction. Scattering of light with objects around us leads to various natural phenomena. The blue color of the sky, the deep sea's color, sunrise and sunset reddening are examples of these phenomena. In a colloidal solution, light's path becomes visible due to scattering by relatively larger particles, a phenomenon known as the Tyndall effect. The Earth's atmosphere contains tiny particles like smoke, dust, water droplets, and air molecules. When light encounters these particles, it scatters in various directions, making the path of light visible. Tyndall effect. The scattering of light by colloidal particles is called the Tyndall effect. Why is the sky blue? The sky appears blue because of the scattering of sunlight by tiny air molecules and fine particles in the atmosphere. Smaller particles scatter shorter wavelengths of light, blue and violet, more effectively than longer wavelengths, red. The blue light being scattered enters our eyes, making the sky look blue. Without the atmosphere, the sky would be dark. At very high altitudes, the sky appears dark because scattering is less prominent. Why is red color used for danger signals? Red is the least scattered color by fog or smoke, which is why it's used for danger signals. Red light can be seen from a distance because it retains its color even in such conditions. Thank you. The human eye is a complex organ that plays a vital role in how we perceive the world. We explored its parts, how vision defects occur, and the science of light, including refraction and dispersion, that helps us understand phenomena like rainbows and atmospheric effects. We hope that you have understood the topic. You can now study chapter notes, watch video lectures, and solve MCQ tests of this chapter on EduRev to ensure you score well in your school exams. And that's not all. You also get amazing courses for maths, science, English, Hindi, and much more for class 10. Thank you